Welcome to the ninth lecture for Mathematics Class 11, Chapter 8, Sequences and Series. We have seen what are sequences and how we can find different terms of a sequence when general n formula is given, or we have been given the common difference or common ratio, okay, with respect to either arithmetic progression or geometric progression. We also saw how we can find the corresponding series, okay, of the different sequences. Then we move to geometric mean. So we saw what is the how we can find geometric mean, and we also solved a few examples. So today we will see two things. First is what is the difference between arithmetic mean and geometric mean, and also that we'll see whether any kind of relation actually exists between arithmetic mean and geometric. So before we go into it, we will first define, or we will first try to see what are the differences between the two concepts. Okay, arithmetic mean, and you have geometric. So mean in a sense means the either the middle term or the central part of any set of data that you have. So when we talk about our arithmetic mean, okay, so this is usually found by summing from by dividing the sum of all the numbers slash given for the given data, okay, by the total number of data points. Okay, so this is how we find arithmetic mean. So usually if you have A1, A2, A3, A4, okay, so your arithmetic mean AM is going to be AN, okay, going all the way up to AN. So you have A1 plus A2 plus A3 plus all the way up to AN divided by N. Okay, so the total number of terms that are there. So this is our arithmetic mean. Now we had seen yesterday what is our geometric mean, found by taking the nth root of the product of all the numbers that given in the given data. Okay, so this is, you can see there's a stark difference in how the arithmetic mean and the geometric mean is calculated. So for the matter, suppose we have A1, A2, A3, all the way up to AN. Okay, so geometric mean GM is the nth root of A1 multiplied by A2 multiplied by A3 multiplied by all the way up to AN. Okay, so you see how the differences are there. So let's take examples and see. Example, we have 5, 10, 15, 20. Okay, we have to find its arithmetic mean. Okay, so arithmetic mean will be given as 5 plus 10 plus 15 plus 20 by 4. Okay, so this is going to be 50 by 4 and this is going to be 12.5. Now you can see this is kind of, right at the, right half of, the both the left hand side and the right hand side. Right hand side two terms and the left hand side two terms. Okay, so this comes exactly between 10 and 50. So this is arithmetic mean. Now let's take the example for the geometric mean. Suppose we have 4, 10, 15, and 24. Okay, over here our n is equals to 4 and we have to find gm. Okay, over here also we had n is equals to 4. So gm can be found out how? We'll find the fourth root of 4 into 10 into 16 into 4. Okay, so this comes out to be 15,360. And therefore, this is going to be the GM that we are going to get over here is 11. Okay, so this lies in between the two, digits over here. But similarly, if you find the arithmetic mean over here, let's see if we get the same value or not. We'll do it for both the examples and we'll see. So suppose we have 4 plus 10 plus this kind of looks like a minus sign, so I'll remove it. Okay, 16 plus 24 by 4. So what do you get this as? 14. 14 plus 16 is 30, 54 by 4. Okay, so you can see that it might not be the same. Okay, yeah, so this is going to be 13.5. Okay, so you see how it has changed. Your geometric mean and your arithmetic mean is not equal in this case. Let's see the same case holds over here. So you will have gm is equals to, okay, so this is going to be what? The product. Okay, now we are going to take 4 root of 5 multiplied by 10 multiplied by 15 multiplied by 20. Okay, so let's see if we get the similar value for your GM as your AM. Okay, so this is going to be fourth root. So this actually comes out to be 11.067. Okay, you see again that your GM is not equal to AM. Okay, so this is a difference we can see that exists, that your arithmetic mean and geometric mean for the same set of data is going to differ. Okay, while your arithmetic mean actually, you can just write it as, and some important points. We can just write it as AM and GM of the same data or set of events are not equal to each other in value. Okay, we saw that the values differ for both arithmetic mean and geometric mean. for a singular set of terms or numbers. Okay. And the other thing that we see is AM gives you the mid or the middle value of the set of data. Okay. Geometric mean identifies the central tendency of the set of data. Okay, so it does not use, it's not supposed to be, or it's not necessarily the the center or the exact middle term. Okay, middle term of the set of data. Okay, it does not have to be that. So these 2 points are important for us to remember, as these are, these stark differences between arithmetic mean and the geometry. Now we will see if there, if any relation actually holds true between these two quantities. Just excuse me a moment. Now we will see relation relation between AM, so that is the arithmetic mean, and GM, so geometric mean. Okay, so let A be the let A be the AM of two positive real numbers. Okay, that's A and B, and G be the geometric mean of two positive real numbers. Okay, of the same real numbers. Okay, so then as per the definition, your A, that is the arithmetic mean, is going to be A plus B by 2. Okay, and your G, that is the geometric mean, is going to be nth root of the numbers. Okay, so we have two numbers, so this is a square. Now, if we take, okay, we take A minus B. So what do we get this as? A plus B by 2 minus root of AB. Okay, now if you get the common denominator as 2, you have A plus B minus 2 root AB. Okay, now you can see that, if you actually, take root of A plus root of A plus root of B the whole square, if you expand it, or actually there should be minus in between. Okay, this will actually give you root A squared is going to give you A. Okay, minus 2, you have root A multiplied by root B, so that you can write as the root of AB, and plus you have root B squared, so that will be B. So this is in the form of the numerator that we have here. Okay, so the numerator over here is the same as, the form, the expansion of root of A minus root of B, the whole square. Okay, so this you can then simplify as root of A minus root of B the whole square by 2. Okay, So this is what we get. Now you can see that this value is actually going to be okay. So this value root of a minus root of b the whole squared by 2 is actually going to be greater than or equal to 0. Okay. So if this is the kind of the, relation that is there, so this means your a minus g is going to be greater than or equal to 0. And this in terms actually denotes that a, the arithmetic mean, is greater than or equal to your geometry. So even in the previous examples that we saw over here, your arithmetic mean, okay, so this is your am. Your am is greater than your gm over here. Okay, and similarly, you can see the gm over here is it's less than your am that we had found. So hence we can see that this relation actually holds true. Okay, and this is an important relation. Okay, this one as well as if you write this as a minus g. Okay, so these two relations are important for us to remember. Okay, with respect to your arithmetic mean and geometric mean. Okay, so this is how we can get. Now let's see some more some basics about your geometric mean, because this is something that is we have seen in a new way. Arithmetic mean is something that we have been doing and we understand it easily. So let's see a little more about uh, some properties of the geometric mean. A moment. Okay, so let's say property of geometric mean. Okay, so the first property that we also noted, okay, in the previous slide, that gm for any given set of numbers is always less than. There might be very few instances, where your arithmetic mean would equal to your geometric mean. Usually, it is, less than the arithmetic mean. Okay, less than the am of the same set. Okay, if each object in the set slash sequence. Okay. So one thing that you have to know, for to find geometric mean, okay, it is not always necessary that your set of numbers that is given to you, it has to be a sequence. Okay, it can be a random set of numbers also, and you can still find your geometry. So, if each object in the set or sequence is substituted by the GM, then the product of the object remains unchanged. Okay, we'll see if we find any examples where this some of these properties can be seen. Then the product of the corresponding items of the GM in two, say, series, the geometric series, are equal to the product of their geometric mean. Okay, so these are some things that you, you can remember. Okay, uh, obviously, if we want to know, what are the applications of geometric mean? Why do we need the geometric mean? Okay, so applications, just to give an understanding of the importance of in your day-to-day life. So usually it is used in stock indexes. So in your stock market, it is used, and it is also mostly in stock indexes and financial market. Okay, so different kind of applications are seen in the financial market. Uh, the AM and GM of two positive two positive integers are 10 and 8. Okay, what are the two numbers? Okay, so now if you remember your, we will first assign some variables to the two numbers. So let A and B be the two integers. Okay, so given is that AM is equals to A plus B divided by 2 is equals to 10, and GM is at 2 square root of AB equals to 8. Okay, so say this is your 1, your 2. So your 1 becomes A plus B is equals to 20. So this can be your third statement. Okay. Now, let's take the second statement. Okay. So taking or squaring 2 on both sides, we get AB is equals to 64. Okay. So this is something we got. Now we will see that you can actually, consider your A and B as, roots of a quadratic equation. Okay. So considering A and B as right, as the two roots of a quadratic equation as, say you have x squared and then you have minus a plus b x and you have plus the product of the roots. Okay, so this is a general formula of the quadratic equation. Okay, so we can find it like this. Okay, now, so we will first find uh, the value of x. Okay, so the value of x can then be the equation that we have is x squared minus 20x plus 64 is equals to 0. Okay, so 64 you can get with respect to 20 is divided by 4, 1, so 16 and 4. Okay, so x, and since this is minus 20, so both of them, if you add 16 and 4, you will get 20. So both have to be negative. So you have x, it's x minus 16 and x minus 4 is equals to 0. So therefore, the two roots we have is x is equals to 16 and x is equals to 4. So therefore, your a can be a. So now suppose we put, a as equals to 4 and b equals to 16. Okay, and therefore, these are the two integers that we have. Okay, so you can see that this is, using the relation between arithmetic mean and geometric mean, it is, easy to find the geometric mean and arithmetic mean of 4 and so your AM, okay, or we are being asked GM first. So first, your GM is going to be 4 plus 5 upon 2. So that is 9 by 2. That is 4.5. Okay, this is your arithmetic. Sorry, this arithmetic mean. GM is actually less than your AM. Okay, so again, it's being reiterated that the values are not equal and also the geometric mean will be less than your arithmetic mean. Okay, so before we move on to the, another uh, the another question, let's also see another concept. Okay, so that is your harmonic mean. We didn't really go in details with respect to harmonic series or harmonic sequence. So just a quick you might be asked different kind of questions. So just in small detail, I will just explain your harmonic mean. Okay, so there is a relation with harmonic mean also with respect to your arithmetic mean and your geometric mean. Okay, so what is your harmonic mean? So harmonic mean, let the two positive integers be a and B. So your harmonic mean is calculated as 2 divided by 1 by A plus 1 by B. So harmonic sequence, if you remember in the first in the first chapter we had done it. So in that we had seen that harmonic progression is each term the reciprocal of each term is also is can actually forms a sequence. Okay, so for it to form a sequence, there even reciprocal of each term also follows a pattern. Only then it would be a harmonic sequence. So if you simplify this, you can get this as A plus B by AB. So this is 2AB by A plus B. Okay. Now, if you remember, we had got our AM is equals to A plus B by 2, and your GM is equals to root of square root of AB. Okay, this is something that we had seen. So this you can also write as GM squared is equals to AB. So you can see that your harmonic mean is showing that if you take 2 upon A plus B, that is actually the reciprocal of your arithmetic mean, and the AB part can be written as GN squared. So your harmonic mean in terms of your arithmetic mean and geometric mean can be written as GN squared, that is geometric mean squared, upon arithmetic mean. Okay, so this gives you a little more information as your geometric mean can be calculated using your harmonic mean. Okay, the product of your harmonic mean and your arithmetic mean, and also your arithmetic mean can be calculated using your geometric mean. So square of your geometric mean divided by your harmonic mean. Okay, so this is also you can see. Now, if you kind of now the relation that we are going to use is geometric mean squared equals to AM into HM. Okay, so your GM then becomes square root of 9 into 49. Okay, so this is actually 218. Let's say it's 44. Okay, so square root of 441. Now square root of 441 you can calculate, and this is going to give you 21. Okay, so your geometric mean from the arithmetic mean and the harmonic mean, okay, is going to be your 21. Okay, so this is this is comparatively easy way to understand. So let's see if we can have a little more, few more sums with respect to this. Okay, the question is if uh, A and G are the AM arithmetic mean and geometric mean respectively, for two positive numbers show that the numbers are showing the relation a plus minus under root a plus g and a minus g. Okay, so this is the relation that we need to show, where your a is your arithmetic mean and your g is the geometric mean. Okay, so we can start by assigning two variables to the two positive integers. So let a and b be the two positive integers. Okay, and then you have your a, that is the arithmetic mean, will be a plus b divided by 2, and your g, that is the geometric mean, is going to be root of ab. Okay, so you can then, can call this your statement 1 and this is your statement 2. Your 1 becomes a plus b is equals to 2a. Okay, and your statement 2 becomes g squared is equals to ab. Okay, so now when we have the values for a plus b and your ab, you can substitute. We will substitute these values in the original equations for that we had found for arithmetic mean and geometry. So then substituting substituting this, let this be 3 and let this be 4. Substituting 3 in 1, we get a. Now for in place of a plus b, we'll put 2a. So a is equals to 2a by 2, and your g squared or your g, actually no, sorry, we will not substitute these in the original equation. I'm sorry, I made mistake. Yeah. So remember the relation that we had found in one of the previous slides, this one. Okay, so this one we will use again, okay, in terms of, kind of finding the, sorry, using the identity. Okay, so we will use the identity. So in place of root a minus b, root of a minus root of b, we will use a minus b. Okay, because we have everything in terms of a plus b right now. So a plus b and ab. So substituting substituting 3 and 4 in the identity, okay, of a minus b the whole square is actually going to be a plus b the whole square minus 4ab. Why? Because if you write a minus b the whole square, so this will actually be a square plus, no plus, this would be minus 2ab plus b squared. Okay, now if you want to, get it in the terms of a plus b the whole square, you need a positive 2 ab over here. So for that, what we do is we have a square plus b squared. You write minus 2ab as it is. Now you will put a plus 4ab. So you can get plus 2ab and to, cancel out 4ab. Okay, you will have to include a negative 4ab. So then this becomes a plus b the whole square. Okay, because this gives you plus 2ab and you will write minus 4ab outside. So similarly, so this is what we have. Okay, so this then becomes then your a minus b the whole squared can be now written as your a plus b the whole square. So 2a b whole square, 2ab whole square. Okay, and your minus 4ab, so that is minus 4 into g square. Okay, so this will be minus 4 square. So now if you expand this, what you get is 4a squared minus 4g squared, taking 4 outside. Okay, so what we are left with is a squared minus b squared. Okay, now you can or simplify a squared minus g squared as 4a plus g and a minus g. Okay, so we can find this is how we have a minus b the whole square. Now what we are asked is to we have to get this relation. So you can then write this as a minus b is equals to, now you take root. Okay, so you taking square root on both sides. What we now get is a minus b 2 under root a plus g a minus g. Okay, so we have this, and this let us write this as fifth one. Now you see your in the third you had 2a. Okay, a plus b is 2a, and over here you have a minus b. So, and if kind of say you substitute for either the b value or a value. Okay, so your a would be 2a minus b, and if you take b, so b is equals to 2a minus a. So you can just write a minus b as 2a. Okay, so 2a is equals to 2a plus 2 root of under root a plus g a minus g. Okay, so your 2 gets cancelled out everywhere. So a is equals to a plus 2 a plus g and a minus g. Okay, so now this is your the value for a. If you substitute your value of a in your equation 3, okay, in equation 3, so what we have is b. Okay, so substituting a in b, we will get this as b, or maybe just write it in the other slide so as not to get it so clouded over here. Okay, yeah, so now we can then write it as substituting a in 3, we get b is equals to 2a minus a minus under root a plus g and a minus g. So then this becomes your a minus under root a plus g and a minus. Okay, so you can see, so this is what we wanted to find, that the two numbers, okay, is a plus minus, a plus g and a minus g. So one is given to a. So a is equals to a plus under root a plus g A minus G, and your B is equals to A minus under root A plus G, A minus G. Okay, so this we can say is hence, sorry, hence 2. Okay, so this is how you can solve. Okay, so you it is easy to kind of uh, use the relation between your arithmetic mean and geometric mean. Okay, and it is easy to find out the answer then. So we will take another question. Okay, let's see. The question is, if the AM and PM A and the AM and GM of roots of quadratic equation are 8 and 5 respectively, then find the quadratic equation. Okay, so it's the it's a similar type of question that we had done before. So, but now we are already given the the values. So let's start with let A and B be the root of the quadratic equation. Okay, therefore the quadratic equation then becomes x squared minus a plus b x plus ab is equals to 0. Okay, now we have the given values. AM is equals to 8 and GM is equals to 5. Okay, so your AM is equals to A plus B by 2 is equals to 8, and your GM is equals to, sorry, GM is equals to 5 is equals to root of AB. Okay, so this you can write as A plus B is equals to 16. Okay, and your AB, okay, if you square both sides, this AB is going to be 25. So therefore, your quadratic equation is then quadratic equation is x squared minus 16x plus 25 is equals to 0. Okay, so this was easy to find because we have been given the arithmetic mean and the geometric mean, and the roots are given as A and B. Okay, so this is how you can use the relation between arithmetic mean and geometric mean to solve sums which are related to these relations. So we will stop here today, and in the next class we will solve many more examples related to all the concepts that we have learned in the sequences and series chapter. So thank you so much for attending.